Number 5. Several people misunderstand this one because it's too easy or something. We have a sled, and Cindy's sitting on top of the sled. She's all bundled up, so she looks funny. You guys wouldn't know what it's like to go sledding. You have to bundle up. She's on a sled and it has a coefficient of friction of 0.12, and we're being pushed across the field with a constant force of 98.7 newtons. And it said the sled has a mass of 4.35 kilograms. We want to know how much does Cindy weigh and what is her mass. Isn't that pretty? Okay, so since it's being pushed across the field at a constant speed, we know that the applied force and the friction force must be balanced. So this is not just my FA, it's also my FF. So if I have FF and I have mu, you say to yourself, hey, I know that FF is equal to mu times the normal force, which is equal to the weight when I'm on a horizontal surface, which I am here. So I said to myself, if I bring this down yonder, I could totally find out what the weight of both her and the sled together are. So let's try that. So we have 98.7 divided by 0.12, and that gives me what?
780 newtons.
That gives me 823 newtons, right? Now, that is going to be the weight of the sled plus the weight of Cindy. Because both Cindy and the sled are pushing down into the ground, right? So then we say to ourselves, hey, I know the mass of the sled if I multiply that by
9.81.
If I multiply the sled's mass times 9.81, that's going to give me 42.7 newtons of this is coming out of the sled. So if I subtract out the weight of the sled, I'm left with the weight of Cindy. So that gives me 780 left, which must be the weight of Cindy. And then I also asked for what is Cindy's mass. Well, once I know her weight, I just need to divide by 9.81, and that would give me her mass of 79.5 cubes. And you had trouble with that problem.